Welcome to day 11, the start of another phase. We have built a fast event-driven microservices architecture, but we have introduced a new massive problem, which is observability. Maybe I shouldn't call it a problem, but a challenge. If a user clicks a button on your front end, that request might travel through our API gateway, hit the user service, make a synchronous gRPC call to the product service, and drop an event in RabbitMQ. If it takes 5 seconds to load, which service was the bottleneck? Today, we solve the microservices murder mystery. We are going to implement OpenTelemetry to trace every single request as it jumps between containers, and we will visualize it all using a tool called Jaeger. I don't know how to pronounce it, maybe Jaeger or Jaeger. You will help me in the comment section. Let's move on. First, our microservices need a central place to send their tracking data. OpenTelemetry is the standard protocol, but we need backend to visualize it. Today we'll use Jaeger. We drop the official Jaeger image into our Docker Compose file, and then it will expose a port for a beautiful web UI and another port to receive OpenTelemetry data. So let me close a number of files and then go to the compose.yaml. In compose.yaml, I'll add a new service. Let me add it at the top. Just minimize these others. Maybe just remove the space. Okay. Anyway, it won't hurt, but I just want them to be together like that. And then at the top, I'll paste. Okay. By now, you should be conversant with this kind of syntax. So we have, this new service. I'm calling it Jaeger. Please tell me how you pronounce it. And then this is the image, Jaeger tracing, all in one, latest, of course, in production, pinned to the current long-term support. Then this is the container name. Then this port 16686 is for the web UI, and this other one is for the receiver. Okay. Like I said, we have a port, and in this case, it is 4317 to receive the OpenTelemetry data. Now we need to teach our services how to track themselves. We shall start with our user service, and we shall also use UV to install the OpenTelemetry libraries, the exporter to send the data to Jaeger, and the FastAPI instrumenter. The magic of OpenTelemetry is that it auto-instruments your app, meaning it tracks your endpoints without you having to rewrite all your business logic. So open the terminal at the root and install the dependencies for the user service. So I will clear my terminal and paste. Okay, so I'm doing a UV add OpenTelemetry API, OpenTelemetry SDK, OpenTelemetry instrumentation FastAPI, OpenTelemetry exporter OTLP to the package user service. Okay, so make sure you have that command and hit enter. So it will take some time. Let's wait for it. So now open the main.py of the user service, and at the top paste the following. Okay, so OpenTelemetry import trace, OpenTelemetry.sdk.resources import resource, OpenTelemetry.sdk.trace import trace provider. We have the batch span processor, the OTLP span exporter, and then FastAPI instrumenter. So we shall of course set up the trace provider. We need to set up the trace provider, think of it as the engine that creates spans, okay, which are just timestamps showing exactly when a function started and ended. Then we're going to configure it to export the data to our Jaeger container on port 4317. And then finally, we shall pass our FastAPI app. And then finally, we shall pass our FastAPI app into the FastAPI instrumenter. That single line of code that you're going to see will automatically wrap every API route in a tracking trace. So make sure you paste those endpoints, and then we're going to include the setup block right after we declare app equals to FastAPI. So right here on line 25, rather line 26, I'm going to have maybe 3 basic steps. Let me just add a few comments just to guide. So the first step will be to name the service so we can identify it in the background. Then after that, we shall tell it where to send the traces, which will be our Jaeger container. Whether Jaeger, please. I won't kill myself. Then the third step, so this was the second. The third step will be to auto instrument. Come on. Auto dash instrument, significant instrument, the fast API app. As simple as that. Now I'll go to the first point and say our resource. This has to be in lowercase. Our resource. Look at that. I'll hit tab. Our resource will be equals to resource.create service.name, and this is the user service. Nice. And the provider AI, please do something, will be equals to the trace provider. Okay, and the trace provider pass the resource as an argument from the previous line. Okay, then now we go to the second point and say processor AI, do your magic please, equals to batch span processor. Okay, and it takes the OTLP span exporter as an argument. Okay, and it will be an instance of it whose endpoint parameter or argument takes in the Jaeger URL. Okay, isn't that interesting? And then of course we're not working over HTTPS, so I'll say comma insecure equals to true, and then we see the provider dot add span processor is this processor from the previous line of code, and then the trace.set tracer provider will be the same provider. Then finally on line 3, I hit tab to autocomplete. We should say FastAPI instrumenter dot instrument app and pass the app. Yeah, I think that is good. Do we need to pass the provider? I don't think we need to. Okay, let me just remove it. If I'm wrong, I'll be happy to learn. Because our user service now relies on Jaeger to offload its tracking data, we need to update Docker Compose, and we shall tell the user service that it should depend on Jaeger. So it will ensure that the dashboard boots up before our microservices start firing data at it. So I'll close this and look for the user service. And then down here, say depends on Jaeger. So dash Jaeger. So now rebuild the entire cluster. From experience, I'll say Docker compose down first. Compose down. Wait for it. And then I want to rebuild Docker compose up minus build. All right, so let's wait to go to the browser and test the Jaeger, whatever you pronounce it. Jaeger, Jaeger. Yeah, correct me. Wow. It's taking some time. We'll wait for it. Let's now go to the browser. So let me try to make a few requests. Execute this. Come here. Try this out. Come here. Put a few things here. Execute. And now go to localhost 8. Was it 8? Why do I cram 8? It was 16686. Hit enter. Okay, look at the Jaeger UI. Let me put back the zoom. So I think this looks not bad. And now I'm looking for certain button. If I choose the user service, okay. There I clicked here, then I chose the user service. I don't know why that color isn't good anymore. Let me refresh. Click user service. Okay. Then operations all last hour. Let me click find traces. Look at that, my friends. Okay. It looks like we have, yes, something showing us the traces that we have so far. So you see it says user service 3. Okay. And we have some kind of like, what can I call it? Yeah, some kind of graphing that we can use to know what is going on in our application. And yeah, I think this is good because it shows you like the number of milliseconds it took, okay, for a request. And that's nice, okay? And yeah, it looks like it's breaking down the internal operations of what is going on and stuff like that. So you can see services, depth. Yeah, this is nice. All right, so I think, yeah, this is nice. So if you look like you have a database query that is running very slow, this graph, I think, can pinpoint exactly where the bottleneck is. And by repeating this setup across all our services, yeah, we can have a really nice view of our entire architecture. So traces are nice, like you see, but only half the battle for now. Okay, if your system crashes, we need the actual text logs. So in day 12, we're going to centralize our logs and yeah, have a better view of the text logs. So subscribe and I'll see you there, but maybe let me make some more requests, okay? Some more quick requests. And yeah, let's see, yeah, how that tool works. So I'll do this again, go to post, try it out, execute, come back here. Do I need to refresh? And you say find traces. Yeah. Now this is better. You see that? I think, yeah, we're moving somewhere. You can choose longest first, okay? You can choose shortest, you can choose most spans, you can choose least spans. Yeah, and this graph, I think, yeah, gives us some good information. Because if I click on this, it tells you there, it's the user service, it's a post request, 4 spans, 1 service, reroute operation. Yeah, not bad. I like this. See you in day 12. Subscribe, like, and share.